Okay, we'll just get that out of the way, and let's just see here. Okay, everybody, thank you for joining us. My name is Bruce. I am a mentor with FRC Team 2852, the Dennis Morris High Voltage Team in St. Catharines. And today, we're going to talk about mechanical tools, and specifically, we're going to talk about using measuring tools, how to measure like a pro and avoid mistakes. So why measure? In an assembly of any kind, individual parts or components must fit with each other. We have a problem in this picture. These will not fit, and this is not the solution. To make a part that fits, we must measure as we make our parts. Measure the round hole and make a part to fit. And remember the motto, measure twice, cut once. The old story of I've cut that piece of wood 3 times and it's still too short happens more often than you think. Measure twice, cut once. So measurement systems. In North America, there are 2 basic systems of measurement. The metric system, or the System International, SI. It's the official measurement system used in Canada and most countries in the world. It uses the meter as the base length unit, uses gram as the base mass unit, uses liter as a volume unit, and it uses pascals as a pressure unit. And a pascal is a Newton per square meter. The imperial system, still used extensively in the United States and still common in Canada. Length is usually measured in inches and feet. Weight is usually measured in pounds. Volume is usually measured in gallons imperial, not to be confused with gallons US. And pressure is usually measured in PSI, or pounds per square inch. So the imperial system, for length, the imperial system typically uses inches and feet. 1 foot equals 12 inches. It expresses measurements of less than an inch in fractions or decimals. On a ruler, these values are represented by lines between the inch mark. So here in the representation, we have the longest line being 0 to 1. So that would be a 1-inch measurement. And then we divide it into fractions. You see the next longest line is 1/2. The next longest after that is 1/4. 1/4 of an inch. So we would have 1, 2, 3, 4 quarters that make the whole 1. Divide again, 1/8. And this particular representation goes down to 1/16 degradation. So this line from here to here, there would be 16 of them in this inch. Now that's all very good, but usually on a tape measure, they don't actually show the fractions. So you will have to determine what those are. And you basically take a look and say, there's the 1/2 inch mark, there's the 1/4, there's the 1/8, and this particular tape measure goes down to 1/16 measurements within the inch of a fraction. So, fractions to decimal comparison. The imperial system uses both fractions and decimals. And what that will look like is 1/2 of an inch is 0.5. 1/4 as a decimal is 0.25. 1/8 is 0.125. Can you see the math? What's happening? We're dividing by 2. We're multiplying by 2. 1/16 is 0.0625. And a 32nd is 0.03125. We won't go any further, but we can go into smaller fractions, but not worthwhile right now. So in this example, you can see that the wood length is shown at the arrow. So we have 3 inches. And then this tape measure, if you take a look, is in 16ths, and we have 1, 2, 3, 4, 5. So we would say the fraction is 3 5/16 of an inch, and that's how you say it, 3 5/16 of an inch. Now, as a decimal, this would be equal to 3.3125. Here's your 16th. There's 1/16. 5 of those. Do the math. 5 times 0.0325 is 0.3125. You will need to become somewhat comfortable in transitioning between fractions and decimals. So the metric system. The base length in this system is the meter. A meter is broken down into centimeters, cm, 1/100th of a meter, and the millimeter, 1/1000th of a meter. The term centi and milli are actually Latin terms. Centi means 100, milli means 1000. The metric system does not use fractions, only decimals, which makes it an easier system to learn and to some extent an easier system to use. A metric ruler is typically marked with centimeters. In this example, we have inches on the top and we have centimeters on the bottom. Within this example, the centimeter is divided into 10 millimeters. You can see that there are 10 lines between 8 and 9. Each of those lines is a millimeter. Both metric and imperial systems are used in Canada. You'll need to become familiar with both imperial and SI systems, and there will be times when you need to convert inches to millimeter or millimeters to inches. Remember this conversion number. This is the number you need to remember. 25.4. Inches times 25.4 will give you millimeters. Millimeters divided by 25.4 will give you inches. That is the metric to imperial conversion for length. So let's start with rulers. Went down to my shop and took a handful of different things that I have there for measuring. So let's just go around and take a look at each of these. The framing square, used typically by carpenters. This one is in centimeters. If you turn it over, it will be in inches, usually made out of aluminum or steel. It has a 90-degree sharp corner, and it's used for typically construction of buildings, lumber, that type of thing, usually working in wood. Also used with metal as well, though. An engineering scale. Back in the days when drawings were made with pencil and paper, engineering scales were used to make scale drawings accurately. The tape measure, we're going to talk about this a little bit later, but common measuring system, very useful, very common. Pocket ruler, very often in the pocket of most tool makers and machinists. A steel 12-inch steel ruler is always popular to have around. And here's a handy little diameter gauge for drills. And it has a series of circles that are specific dimensional sizes, in this case, fractional dimensions. And it will be used to either draw a circle with a pencil, or if you have a drill and you don't know what size it is, you can slide it through the appropriate hole and it will tell you how big the drill is. It also has some chevrons here, and I will talk about that a little bit later. That is drill angles, included drill angles. So let's talk about tape measures. The steel tape will recoil into the case very quickly. It can happen quickly, so watch your fingers. So this is a typical tape measure. It has typically a plastic body, very often wrapped with a rubber casing. It has a lock lever that will keep the tape from sliding in or out. The steel tape itself, which has the markings on it, and then the end hook, which is a handy little gadget for a number of reasons. The end hook is to hold on to the part as you pull the tape out of the body. and it will allow you to leave the tape at one end and pull it out and use it as a second hand, if you will. The end hook has some movement on the rivets to adjust for inside or outside measurements. This is normal and it needs to be there. So the end hook will slide back and forth a little bit. The movement is equal to the thickness of the hook. And you can see that dimension between those two red lines, that is how much this will move, and that is how thick that end hook is. When applied, the lock lever will prevent the tape from moving. So let's talk a little bit more about tape measures. Tape measure blades come in a wide variety of styles. Inches on both sides, inches and fractions on the top of this one, and centimeters on the bottom. Inches on the top on this one and fractions on the bottom, which is handy if you're not comfortable with the fractions. And then inches and decimal inches, which is also an unusual style, but you may see it. The one at the top is typically used. Another typical one is inches on the top and centimeters on the bottom. Those are the two most common types. Some do's and don'ts with tape measures. Make sure the tape measure is in good condition before using. If you have a worn or damaged tape measure, you can get a bad measurement and things will not fit. If a precise measurement is needed, avoid the end hook. Start at the 1 inch or 1 centimeter mark, measure, and then don't forget, subtract the 1 inch or the centimeter. If the tape has excessive movement of the end hook, do not use the hook to measure. It will give you a bad measurement. Don't clamp, pinch, or make a tight fold in the tape. This will leave a permanent kink and make it difficult to use the tape in the future. Do keep your tape clean. If it gets dirty or greasy, wipe the tape with a clean rag before it goes back into the case. The dirt and grease will prevent the tape from recoiling and locking correctly. Try not to let the tape recoil too fast. This can damage the end hook when it stops suddenly, when it ends the recoil. So some tips and tricks with tape measures. Use the slot in the end hook to securely hook onto a nail or screw. This is like a second set of hands if you can't manage to keep the hook on the piece that you're trying to measure. That is specifically why that is in that hook end. Hook onto a nail, attach a pencil to make a compass, to make an arc or circle. Another tip, if you've got repeat measurements on multiple pieces, mark the dimensions on the tape with a erasable marker. Make your marks on the wood and then wipe the marks off when you're done. You can see we've got some black marks between 4 and 5 and 8 and 9. Make a rough straight line from an edge. Another neat feature of the end hook is it has a pencil notch. You can see the notch right down here. And if you hold your finger at the 6-inch mark, put the pencil in the pencil notch, you pinch the blade, and then keep the blade perpendicular to the edge. Slide your finger and tape along the edge to make a line. Not 100% accurate, but if you need a quick line to cut a piece of wood, works well. Did you drop that nut deep down into your robot or that tool from your ladder? Attach a small magnet to the tape end hook to reach and grab it. Handy little carpenter trick. Inside measurements, they can be a little bit tricky. Two ways to do it. You can place the hook against one side and then gently bend the tape into the corner, and then you have to estimate the center of the bend. Not the most accurate, but gives you a quick idea of what the inside dimension is. For more accuracy, you place the tape tight to one corner, then run the tape out tight to the second corner. You read the tape length at the body, which would be right here, and then add the body width. The body width is typically shown on the side of the tape. In this case, you would read your measurement, add 3 3/8 of an inch, and then you have a more accurate inside dimension. In wood building construction, wall studs are generally spaced at 16 inches. Wall studs are just that vertical 2x4 that they use to attach drywall and other sidings. So they're at 16, 32, 48, and so on. The tape, imperial tape measures, show a red highlighted number at 16, 32, 48, and so on. So it's a handy way to mark very quickly the positioning of wall studs. So let's talk about digital calipers. This is my handy dandy caliper set here. And let's just take a look at the different features of calipers. You have outside measuring anvils. At this point, you have inside anvils for measuring the inside of a hole or depression. You have a button which switches from inches to millimeters. A locking screw to hold the slide. Battery compartment. This is the caliper body, and this particular one has millimeters on the top and inches on the bottom. The depth measuring blade, talk about that in a moment. A fine adjustment knob, which allows you to put your thumb on that and slide back and forth very accurately. The thumb grip, if you want to just grab the body or grab the slide and move it in large motion. The on and 0 button, and the off button, which on my particular calipers is very important because my calipers do not shut off automatically. And you can lose a battery very quickly if you forget to turn it off. Most of the newer calipers, however, do have an auto shut-off feature. Okay, so let's talk about reading digital displays. As we talked, there are two systems, inches and millimeters. You can see them identified in the window. So let's talk about inches first. We've got 1.1395. If we break that down, it's 1 inch, a point or decimal, 1/10 of an inch, 3/100ths of an inch, 9/1000ths of an inch, and this particular set goes down one additional digit to 10ths of a thousandths. And underline is what we would usually call that. 1 inch, 10ths, 100ths, thou, and 10ths of a thou. On millimeters, 28.94. I put an extra 0 in there for a reason. So 28 millimeters, there's your millimeters shown as mm, a point or decimal, 9/10ths of a millimeter, 100ths of a millimeter, and 0 or thousandths of a millimeter, or in metric, we call that a micron. So let's watch a short video on how to use digital calipers. Okay, we're going to do some measurements with a digital caliper. 4 different types of ways to use digital calipers. But before you do anything, as soon as you pick calipers up, you should open them up, wipe the anvil surfaces that you're going to use, make sure that there's no dirt on them. Make sure that there's no damage to the sharp points. Be careful of the sharp points. And then bring the anvils together push the on 0 button and get a 0 reading. Open them up, bring them back, should remain a 0 reading. For an outside dimension, we're going to use the outside anvils, and we have a shaft with an outside diameter. We open the anvils, bring them together with a moderate amount of pressure, and we read 5.005 inches, half an inch plus 5/10 of a thou. So that's an outside dimension. For an inside dimension, we have a washer. We would like to know what the inside dimension is. We have to keep it horizontal to the anvils, perpendicular, if you will, and then bring the anvils out to capture the part, move it to make sure that it's in the right position. And in this case, we get 7.630, so just over 3/4 of an inch. We want to make sure that we don't have the washer off center like this. That will change the dimension. You want to make sure that you don't have it twisted up or down. That will change the dimension as well. And the other thing that will change the dimension is if you apply too much pressure on the thumb wheel, you can twist and stress the anvils a little bit and change the numbers a little bit. You can see that by applying some pressure, I can change the numbers. Not a lot, but a bit. So you keep just a moderate pressure on them to give you an accurate value. So that's an inside dimension. The next thing we're going to do is we're going to take a look at the blade. This is the depth blade. And this piece is an arbor. It's a shaft, basically. And it has a hole down the middle of it, a threaded hole. But we would like to know how deep that hole is. And it looks quite deep. So what I would like to suggest is bring your blade out, bring it in until you hit the bottom of the hole, and then you bring the blade, the body of the caliper down until it hits. And we want to make sure that it hits evenly. And there is the point right there. So we have a hole that is 3.0275 inches deep. We would say that's just a little bit over 3 inches. So that is how you measure a hole depth. The final way to measure something is using the step feature. You can see this shaft has different diameters. There's actually 3 different diameters. The main diameter, 1 step diameter here, and then a 2nd step diameter here. If you look at the end of your calipers, you'll see that these 2 surfaces are ground to a flush surface. And if you bring those surfaces apart, you can see a step forming. That step is what you use to measure. So you bring those 2 surfaces against the steps. You make sure that they're tight against each of the steps. This surface and this surface against this surface and that surface. And the value is 0.5425. We'll show you that again. With the 2nd step, you bring this surface against there, and then bring this one down until it just contacts. The 2nd step is 0.9445. So those are the 4 ways that you can
use your digital calipers. A couple other things that you should know. Obviously, if you press the inch to millimeters, you can change from inches to millimeters, depending on what system you're working in. If you have a number that you want to keep, you can press the hold button on this particular model, and it will not change. If you are making a number of parts and you say, I want 10 parts that diameter, you basically set the diameter. In this case, in millimeters, it's 12.72, and you can just snug, not too terribly tight, snug that thumb wheel, and it will hold the size. So now, all you do is you make your parts and you measure. Make a part and measure. Remember, don't tighten it too much. We don't want to overstress the threads on this. And that's about it. Thank you for watching.
Okay. The basics of using digital calipers. So some errors, common caliper practice to avoid errors. Make sure the part and caliper anvils are clean. First thing you should do when you pick them up is wipe the anvils you're going to use. Make sure your part is clean. Use a light pressure on the part. Too much pressure will change the reading. Keep the part and calipers aligned with the measurement you want. If you have the part twisted, as you see trying to measure the thickness of this ruler, you will get an incorrect measurement. The picture on the left is wrong. It's not aligned with the actual width. On the right side is the right alignment. So be careful that you have everything aligned when you're taking your measurement. Twist drill bits are often left on workbenches or in the drill chuck. They should be returned to the drill index so the next person knows what size they are. A little thing that drives me crazy. You find drill bits lying all over the shop. Bits have the size marked on the side of the shank, but it is often marred and unreadable. So you measure the shank with digital calipers to determine the size. In this case, 0.3125. As a fraction, we would say 5/16, and that's the hole that it would go into in your drill index. Some errors that creep in. The anvils have a flat contact face that gives an error on small holes. In this picture, we can see the anvils on both sides of a small hole. And I don't know if you can see it. Let's zoom in. Where the anvils contact, there is a slight gap right here. And that is a measurement error. It's on both sides, so it's ×2. So if you're looking for a reasonably accurate measurement, it's okay to use them on inside holes like that. If you need an accurate measurement though, you need to use a different tool. You use telescoping gauges, or you can size it with a drill. Telescoping gauges have spherical surfaces on spring-loaded plungers that you can put into a hole. Then you lock the size, and then you measure the size of the gauge with your calipers. Let's talk about squares, framing, engineering, and speed squares. Basically, we're talking about 90-degree squares, and they look like this. This particular one is 24 inches by 16 inches, and it's a framing square used by framers and builders. It's called a rafter square, and it's designed for carpenters and builders to make sloped roof rafters. It's a common use for it. And they use these ratios here and the numbers along here to make rafters. Probably won't be making robots out of wood, but it's a good thing to know. This is a speed square, which is similar to a rafter square. Once again, it can be used to make angles, and it's a little bit smaller and easier to use. It's only about 7 inches on each side. An engineering square is merely a right angle blade and body. There are no measurements on it. It's basically used to check that something is flat and rectangular and square. So the different types of squares. Now, handy little device, the combination square. You'll see these, and there's a number of things that you can use these for. Now, this particular one has a steel sliding ruler, and it's in inches and millimeters. Centimeters, actually, more correctly. The square body, a locking thumb wheel so that you can lock the body onto the steel rule at a specific dimension, in this case at 4 inches. It has a 90-degree surface for measuring 90-degree or marking 90-degree lines. And it has a 45-degree surface, which can be used to make an accurate 45-degree angle. It also has a nifty little spirit level here, a level indicator, which when you're using the 90-degree surface can check that something is level. And the final doodad is a pull-out scriber pin. These are typically threaded in, and it's a steel needle, if you will, that can be used to scribe or scratch a surface and make a mark. Mechanical levels. Levels come in many materials, lengths, and designs. They can be made out of plastic. They can be made out of aluminum, either tubular or cast aluminum. Lots of different types and styles. Here's a torpedo level, and you can see that it has 3 different level bulbs on it, level cylinders. One at 45-degree angles, one at 180 for flat surfaces, and then a one at 90 degrees for vertical surfaces. The level bubble needs to be exactly in between the lines to make a level part or level assembly. Sometimes called a spirit level because of the alcohol in the bubble glass. Why alcohol? Alcohol doesn't freeze on the job site when you're working outside. And just so you know, it's the poison type of alcohol. Compass and dividers. Not used as often as previously, but a compass will draw a circle using the center point. The center point is the sharp point here. You place it on a piece of paper, wood, or metal. And then you have a pencil lead element here that you can twirl the compass with your fingers around the pin and make a circle. Dividers can be used to measure a line segment and transfer to a second piece, make a multiple measurements, marks of a constant length, or as a map reading tool. Once again, similar to a compass and not used terribly often, but you need to know what they are. Now, the divider will also scribe or scratch a circle. Can be used that way as well, instead of a pencil. So let's talk about some other devices that would be used by tool makers, machinists, or mechanics. We'll talk about micrometers, indicators, gauge blocks, sometimes called Joe blocks, and feeler gauges. So here we have some micrometers, a 0 to 1 inch micrometer and a 1 to 2 inch micrometer. And micrometer has a body, it has a spool, and then it has a slide body here. And these bodies have Vernier scales on them. A Vernier scale looks like this. And as you spin the spool out, it's threaded, and it will accurately give you dimensions. Now, we won't bother learning how to read these today, but they can give you a very accurate measurement on a part that you are putting between the anvils. The indicator shown here is a dial with a probe, and typically they're mounted on a stand, and you slide it against a part to measure the flatness of the part. Gauge blocks are made out of hardened steel. They will be ground to a very precise dimension, and you can see that there is a whole series of thicknesses of these blocks. The blocks can be pressed together to build a specific dimension, and then you can use those blocks to fit a part, whether it be a gap or a height or whatever you're doing. Typically used in precision manufacturing. Finally, feeler gauges, a handy mechanics tool, and these are thin blades of metal that have very accurate dimensions ground into them. So here, this one is 0.016 inch or 0.406 millimeters. You can stack some of these together to create a specific thickness. And these are commonly used to gap spark plugs or check other gaps where you need something very accurate. Angle gauges, protractors and variable angle gauges. You may be familiar with the protractor from school, used to measure angles, and a variable angle gauge, which has a steel ruler that can be set to a specific angle, locked in with a thumb wheel, and then you can draw an accurate angle on a part before you want to cut it or measure or build it. Let's look at a twist drill bit gauge. This is a handy little device. Remember I talked about drill included angles. Drill bit angles usually come in 118 or 135 included angles, and you can see those marked on this gauge. This gauge will allow you to check that the angle on the drill is correct, and it'll also show you the diameter of the drill. And this scale is specially made so that it can measure a diameter on an angle. Let's talk about infrared handheld thermometer. Handy little measuring device, and it measures heat. It does it with infrared beam and some slick technology to measure the reflection. It can be used to measure motors, bearings, belts, and gearboxes for over temperature. And I talk about over temperature because it will warn of impending failures due to high heat damage. When motors and bearings and other things start to fail, they typically will start to heat up. They will heat up until they seize and then stop turning. And when things stop turning, the robot does not move. It's a non-contact operation. Sometimes it's difficult to aim into machinery. And medical grade devices are used extensively by healthcare professionals. And we all know about the things that are going on with healthcare professionals at this time with COVID. Finally, let's talk about pressure gauges. They're generally specific to the gas or fluid that's being measured. They're attached to a pipe, usually with a thread. You can see the thread on the bottom of this particular one, and they will measure air, oil, welding gases like oxygen or acetylene, water, and any other type of fluid or gas. Dials are often marked with multiple scales. Imperial is typically PSI, or pounds per square inch. SI can be a little bit different. Be measured in kilopascals, bar, or kilograms per centimeter squared. They very often have dials with numerous scales on them. This particular one in the middle is showing kilopascals in red and PSI in black. And thank you for your attention. That concludes this presentation. We do have a Cahoots, and we will perhaps put that on a different video. Thank you for your attention.